Okay. As far as I know, we're live.
I can see it.
All right. Well, welcome back to another episode of Composites Weekly. Today, I've got Nick Ciparro. He is the Chief Technology Officer at Advanced Composites of Carbon Rivers, and happy to have him on the show. He's got a pretty wide background, but we're going to get into some of the stuff that he's been working on in advanced materials and composites. Talk about some of the work over at Carbon Rivers, a company that develops and commercializes technologies such as second generation polymer composites, graphene based materials, and other additive manufacturing materials. So excited to have Nick join me on today. Nick, thanks for coming on and spending some time with me.
Thanks for having me. I think it's great to get the word out and discuss some of these things and try to present it in a podcast format is pretty good because you can get it to the layman.
Yeah, exactly.
One of the keys is if you did some kind of seminar at a university somewhere, or whatever.
Yeah.
Half the crowd is asleep and half the crowd wasn't even there for your thing. So who cares?
That's right. That's right. Yeah, I love this format. I mean, no one reads, people read technical papers, but they're just not as exciting as, and like you said, going to events like that can be kind of dull. I like to liven it up a little and have guests on like yourself. And it's kind of fun just to talk about not only what you're working on, but a little bit about the background. I like some of the story, the background, yourself, how you got into this industry, and some of the work that you've been doing since. So why don't we start with yourself? Because you've got kind of we had a conversation, prior to the podcast, and you got, you're just like a Renaissance guy. You kind of started in one field and then you transitioned into advanced materials and composites. I think you started out as many years back and as an audio engineer, I believe. And I'm, as a guy that does podcasting, I'm always fascinated with that. And how did you make that? How did you make that transition? Well, because I can tell from your profile, you got the long hair. You probably, did you grow up like a heavy metal guy? I mean, into heavy metal and.
Well, kind of. I mean, my favorite band is actually Led Zeppelin, so it tones it down just a little bit.
There you go.
But if you're talking about Meshuggah, I know Thomas Hawk, so or I know him as in business relationship. We met or this or that or worked together and blah blah blah. That's it. So things like that. Honestly, when I was young, I wanted to be an aerospace engineer.
Yeah.
So that kind of picked out what I wanted to do, and I was already technical savvy, and wanted to be into technology.
Sure.
And then it was high school, and I was playing guitar as a hobby, and we actually had a show and tell. I went to Halls High School, and a friend of mine brought an acoustic guitar, and I brought a jet plane that I had built, hand built RC model, this and that, and I did my little presentation at school, and everybody's like, yeah, whatever, they didn't even care. And I'll tell you this, it was Sean, he knows his last name, and I won't out him, but he came up there and played the guitar at back then, as good as a 16-year-old kid could play.
Yeah.
And I'm like, I can play just like that. And I'm watching all the girlies just stare at him and laser beams into this dude. Yeah. And so it's but I can play better I actually can play better than that, because it was a hobby, but it was
right.
And I'm like, oh, I'm in the wrong business. What am I trying to do? You can't get girls with airplanes. You can fly them across the country, but they don't care.
Right, exactly. Yeah.
So at that point, I was like, I'm getting into the music industry, and I did everything I could. I could, when you say, actors a lot of times will do, they'll wait tables to supplement their acting career.
Yeah.
And then they finally get a movie and they get a break. And
sure,
that's the same thing. I cooked in kitchens. I, did this and did that. Any little odd car washes, it didn't matter. Okay.
Yeah.
just to make enough money to keep this music career, this dream alive.
Yeah.
And it really started panning out about when I was about 18. I was, working at a radio station when I was like 16, 17. Then I got to do some jumping back and forth. My band was, I had bands that were kind of quasi taking off. I thought, in reality, they were just garage bands that played at somebody's party. But, it is what it is. You think you're doing great things and the biggest thing in the whole world. Looking back, it was nothing until about 2004 when I was full-time at, if you remember the venue, Blue Cats. I was managing the stage there till like 2008 when it shut down because of the housing crisis and stuff like that.
Yeah.
And if you remember the Valerium, I worked there as well. And
wow.
So I worked with an array of bands from like John Mayer to Disturbed, Maroon 5 to, Seven Dust. I mean, just this plethora of bands. And while I was doing that, I, about halfway in it, you get on a tour bus and you're like, you got nothing to do and you're playing Gran Turismo all day. And you go, man, this building a race car, how hard could it be? I could do this in my backyard.
Right.
Well, wrong, but yeah. Yes and no. So, in the great words of Jeremy Clarkson, how hard can it be?
That's right. Yeah.
I can tell you how hard it can be. So I started building a race car. And then when I got out, I kind of like retired out of the music industry, sold everything. Like the race car that I was trying to build, I wasn't even close to being done. I mean, I was pseudo, but knowing now I have a race car, I wasn't close.
Yeah, right.
So again, it's so many times you think you're close and you're really not.
Sure.
And so what happened was I sold most of the stuff and tried to get my life like consolidated because, it was a tough time in 2008, 2009, 2010. And then around 2009, like after I had already sold everything and done everything, then I saw a YouTube video of this electric car called the White Zombie. And it is a 1970, I think it's 76 or 79, somewhere in there, Datsun 2000S. Just this little, not impressive, not fast car. But they put an electric motor in the back, a 12-inch DC drive motor with 10 lead acid batteries in it. And it was demolishing full-blown Vets, Mustangs, everything. And I'm like, well, I wanted to make a fast car. Electric car seems like it's fast.
Yeah.
I can do that. And why wouldn't I just put 4 of these motors in the car instead of just one?
Right.
Because of course, this one goes to 11. So I was trying to figure out batteries and I was getting into the battery chemistry thing. And, being the kind of person where I'm like, well, I can do it myself. I don't care. I mean, I literally fixed a guitar amplifier one time with a needle, chopsticks, and a lighter, like super MacGyver.
Yeah, I was going to say, that sounds like MacGyver.
Yeah. Dun, 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 dun. Anyway, so let's start playing that music on the keyboard. But so I was like, why not do that?
Yeah.
And I saw that the batteries was the limitation. So I started kind of looking into how batteries were and supercapacitors. And I ran into a paper from Drexel University. And I was like, I could make those supercapacitors because what I saw in electric vehicles was either A, you have this range anxiety, because like that little White Zombie could only go like 100 miles before it had to be completely charged.
Sure.
But it took like 3 days to charge it.
Ooh,
because,
man.
He had to use a trickle charger and all that
stuff,
and it is what it is. And I'm like, man, that kind of sucks. And I was thinking, well, what if you could get like 250, 300 miles out of a car? Okay. And then Tesla came out with the Roadster, which had like 150-mile range. And I was like, they're getting closer. And it looks possible because they got these lithium ion batteries. But I was like, I can't afford lithium. I can't make lithium ion batteries and I can't afford to make them. And back to the supercapacitors where it looked like I could possibly make these stupid things. So I was like, I can make these in my basement. I can figure this out. And so I was trying to work on that and knowing that you could make a supercapacitor, which is a battery that charges incredibly quickly. It has less density, but it also weighs less. So if you make, like, you can buy from a company called Maxwell supercapacitors, and you can make a car that gets like 250 miles in range, and it charges in about 3 minutes flat. But the battery itself, if you didn't make your own supercapacitors, it'd be about $250,000 in batteries alone.
Oh, wow.
I mean, they're not cheap. I mean, just one scale cap. I have one at home. It's like a big D battery, and those are $23 each. So if that gives you an idea, I mean, it's just like, whoa, that's cost prohibitive. Again, me playing, you know, I wasn't rich. I didn't have a lot of money, and I wanted to do something. I wanted to reach for the stars, if you will.
Sure.
And why not? You know, why not figure out what we want to do by, you know, doing what we want to do. And then I met the guy who wrote that paper from Drexel, because at the time, after time went by and I'm trying to tinker around and learn how batteries work, I took a course called MIT 6002X, which is an electrical engineering course, and went through that. I got my associate's degree from Pellissippi. You know, I was like trying to flip my career, you know, go from music and entertainment to like something else. And during that time, the irony was that I was, you know, working with recycled electronics or repurposed electronics. A friend of mine, he has a big facility here in Knoxville. I mean, it's not huge, but it's decent size. And he'll get like old Google servers and then just wipe the hard drives and then sell them off to a new company, because an old Google server is still really good. Or he gets Zebra printers from like Kroger's. And then like these individual stores will take those Zebra printers and buy one, because you need a Zebra printer, you know, to print off little, you know, your, you know, coffee shop receipt. So it's the same exact, you know, receipt printer. And he also did the dog collars from Petco, because he would get all their returns and then fix them and then put them out there, you know, and he did all kinds of, you know, it was neat. It was a cool thing. Yeah. He does a very neat thing instead of just throwing it away. So I finally, my girlfriend at the time, later now my wife, she was a chemical engineering student at the University of Tennessee, actually a doctoral candidate. And they had an energy storage conference hosted by her professor, but it was all fuel cell stuff. They didn't kind of market it that way. They just said it was fully energy storage, but fuel cell is more like, it's not necessarily energy storage as much as it is energy conversion. So I'm there kind of bored, but having a good time, because we were on that little, you know, down the Tennessee River, the riverboat.
Oh, yeah.
And
cool.
You know, you're just having a good time. I meet the guy who wrote the paper from Drexel. And Volker Prosser, he's actually huge in Germany right now for their energy commission or whatever. He wrote that, and he was like, yeah, you know, with that, you have to sort the particle size, and the particle size distribution is kind of hard to do. You know, it's very, very limited, this and that. And I was like, huh. And he goes, what you need is something with a very specific particle size distribution, better conductivity, and really good surface area. And I was like, this is 2010. And I'm like, I remember reading this paper about these dudes in England. What was that stuff called? So I went back, Google searched, you know, because I was going through papers and papers trying to learn stuff. And there it was, graphene. And at that point, I was like, okay, I'm going to buy this graphene. I'm going to buy this stuff, and I'm going to put it in my supercapacitor instead of using because they were using activated charcoal, like basically burnt coconut shells. So I was like, I'm going to make this. I'm going to make this battery with this graphene in it. It's going to be awesome. Wrong. I called Fisher Scientific. I called all the, you know, the normal outlets, and they were like, yeah, we don't have any, and when we do, it's going to be $1,000 a gram. And I'm like, well, then I'm going to have to figure out how to make graphene. And that's when I started doing this embarkment of like, I'm going to make some graphene and I'm going to use it in these batteries. And that's where my YouTube started way back when. And, you know, it blew up in front of me. Like there were some videos with 150, 200,000 views, stuff like that. I mean, it was crazy. You would Google graphene, and if you did like the search, it would be like my YouTube would come up first. Yeah. And then the videos of the top 5 videos, I believe 4 of the 5 were my stupid little, I mean, this is what I was doing. I was holding the phone like this and just
yeah. I mean, it's impressive. You took told me that page. I checked it out. And so it's, I mean, some of those are just crazy, just what I call ghetto type videos, but they're really informative.
Dude, that's what I was doing. I was just trying to like, this is what I'm learning as I'm going along. And then I got invited to the University of Tennessee to come do research there and everything like that. Mm-hmm. And you know, some professors were very good to me and said, hey, why don't you do this here? And I'm like, cool. But I was trying to make this graphene. And then at the time I was making GO and RGO, which is, you know, the original, they were trying to do these things were like modified Hummer's method and all this like heavy acid chemistry and like just really, really, really highly unrecommended stuff. In fact, one of the videos that I did was it didn't pass the health and safety committee thing for YouTube and got pulled down, even though it had like 250,000 views.
Right.
So, you know, it is what it is. I understand they don't want people, you know, 98% concentrated sulfuric acid in a gallon bucket. I mean, that's dangerous. And it really is. I mean, especially if you're just doing it silly, like I was doing it. But I was taking precautions and it, you know, it was what it was, but you know, some kid could possibly, you know, whatever.
Yeah.
That being said, after I was testing these batteries in this RGO, I was not getting the results that were like being claimed by people in England and, you know, in Europe. They were all saying, you know, we could possibly, but that's when I realized there's a caveat in like scientific theory where they theorize what possibly could be done rather than what's reality. And that comes back full circle in just a few minutes. So I went back and I was like, how do I make that just that single atom thick, just no function group flake of, you know, separating that, you know, if you think about graphite as a book and you pull that one page out, that's the graphene. So how do I get to that? How do I get to that? And honest to God, it was, again, luck of the draw of me just associating things. I was sitting there with 6 chemical engineering, chemistry, organic chemistry, and a physics handbook all laid out. And I was just trying to, you know, get some references. And I swear to God, one page, the bottom of one page read into the top of another handbook. Like if you just read it continuously instead of, you know, separate pages. And it was like, well, that's 90% of it right there. And I was like, I mean, I still get goosebumps, you know, thinking about it. I mean, it was just like so easy. It just, you know, my wife's father said, yeah, it seems like the hand of God just came down and pokey you because he's Chinese. So, you know, it was really, really funny because of how he described that. But it was true. It was just, and I had a machine shop in my basement because that was a little thing that I like. I like to be able to like hands-on make things.
Absolutely. Yeah.
So I had a little lathe 3-in-1 system, you know, drill press / milling machine / lathe. And I'm like, I'm going to make this machine. I'm going to make this thing. So I did it. And the joke is that it looks like a really big tamale pot with like wackiness going on in it. And I made it. And I brought it upstairs and it ran off a 220 volt, like, you know, like your oven or your dryer. And I moved my oven out of the way in my house and plugged it in and turned it on and it exploded and put black all over the kitchen, just demolished everything. Yeah. And my wife was like, well, that's not happening anymore. That stays downstairs in the garage. So
at least she was probably a little more understanding being a material scientist, right? I mean,
no, she's a chemical engineer, but yes, absolutely.
Chemical engineer.
Yeah, she was just like, now clean it up, you guinea brat. No, I'm just I mean, she had just learned The Godfather, you know, the part where she throws the plates down and he's like, well, that's basically what I got. Yeah. Being Italian, I kind of laughed and had fun with that. So I cleaned up the kitchen, brought it downstairs, fixed what went wrong, turned it on, and I had hypothesized a certain resonance time and this and that, ran it, pulled it out, got the samples out, and then used our network of friends who were also chemical engineers and material scientists and this and this and this and chemists and all that. And I just handed them samples, like 5-10 gram samples. And I handed them these samples and said, hey, tell me what you see on this. Like the guy who runs a TEM, you know, I don't have a TEM. Do you? Because they're $2.5 million sometimes. The one at UT is like $1.7 million. Well, he went in there, looked at it, and he comes back and he goes, man, I don't know what to tell you, but this looks like literature. This looks like the theoretical stuff. And I'm like, awesome, because I'm about to put it in this battery and see what happens. And I put it in the battery, and it blew away all of my expectations. Before we were taking raw graphite and putting in a PVA based electrolyte, because these batteries are real simple, really easy, So we would do this, phosphoric acid, PVA, electrolyte in the graphite. Then I did the RGO and graphene oxide, and you would see maybe a 2% increase. And you put this graphene in there, and now we're seeing 150, 200% increases in charge density, like that.
Wow.
And I'm like, whoa! And then I was screwing around, and I was like looking over, and I remember that we were fooling with some polymers in the lab, and it was nylon. And I was like, stuff, weird phenomena, magic dust, plastic.
Yeah.
Why not? Let's see what happens.
Sure.
And it's on one of the YouTube videos where I was mixing it with a glass rod on a hot plate on a non-stick pan from like TJ Maxx. Just who cares? Yeah. And I mix it up, and then I tried to fool with it, and it just would not break. And I'm like, I know how strong nylon is. And then I had this stuff. Now, mind you, we were way up there in loading, and it was so stiff. And I was hitting it with a hammer, and I was trying to break it with wrench. And
yeah,
it was crazy. I was like, we could do anything with this stuff. And that's when, about the same time as when England was like, it can go in anything. It's amazing. And we're like, all right. And my lab mates, my friends in there, they were like, whoa, we just started theorizing and just trying anything and everything. So time goes on, and basically I start this company. We start manufacturing here and there and, different places. And we didn't know this, but the volume that we could produce was more than anybody in the world. In fact, the one big plant that I made that my wife's father helped us put together was literally making more than everybody in the world combined. That's the number. I mean, it was incredible, the numbers that we were getting out of it, because this process is super simple. I mean, it's not simple, but it's not difficult as long as you have the right machinery and And sure. Ironically enough, my music background, that's where this comes in, is what helped me get the frequency and the things that needed to be done inside this thing to actually get it right. Who knew? If I didn't have a music background, it would never have happened. Never. And so that's where that stacking of like skills is silly.
Oh yeah. Yeah, absolutely.
And then if I hadn't ever, if I hadn't cooked in in restaurants, I wouldn't have known that there's a, you saute stuff, and stuff like that. If you're sauteing, there's a certain timing. The pan has to be this hot. It has to do this. It has to, there's certain steps that have to be done or it won't come out right. Well, that kind of mentality, if it's forced in you innately, then when you try to do chemistry, which is basically cooking, you now get your results. And it's just miracle. I got lucky on, and I say this over and over and over when we have our tours of our facility, is that we're not the best material scientists and engineers in the world. We just so happen to be lucky enough to be in the presence of the magic dust that makes all of our stuff awesome.
Sure.
Because it's not, and I have some examples here on the desk here where it's just like, what? How did you do that? And it was like, we just did it. It was just,
you gotta have the right stuff, right?
You
gotta be working with the right tools, the right materials.
That's exactly right. Like, all right. So one example I'll do some show and tell. This is a film. So this is just ultra high molecular weight polyethylene, like what goes on the bottom of skis and snowboards and cutting boards.
Right.
Okay. This is really, really, really anti-abrasive. And in fact, it's 10 times more abrasive than resistant than stainless steel. So you can take this and put this, what we're working on is, this curve kind of is part of it. We work on putting it on the front of wind turbine blades because Carbon Rivers does a lot of work with wind turbine blades.
Sure.
In fact, we're the guys that are actually recycling this stuff and breaking the fiberglass down, extracting the glass, cleaning it up, putting it back in mats so that, automotive OEMs can use it just like brand new virgin fiber.
Right.
And then we do the same thing with OEM automotive parts. Trust me, I have quite a few vehicles worth of material. I won't say which brand, but just think about a fiberglass sports car from somewhere in the United States, not too far from here. That being said, we do their recycling, and fantastic. I don't want to give away all the secrets, but we do that for them, and they love us for it. And we love them. We love them just as much as they love us, because I enjoy looking at their cars. They're very, very nice.
Oh yeah.
Knowing the quality control that they have for their parts, like if it has just the tiniest little, they're like, not give it to Carbon Rivers, recycle it. Rather than body shop refabricating and everything. This is one example. But then we have like foams. Like this is a we put a blowtorch on it for quite some time, but it won't burn.
Wow. And
so this is just polyurethane foam, like with all these different. You've seen it, everybody's seen probably the TikTok or Instagram videos where they're blowing it in the walls. I mean, that's what this is.
Yeah, spray foam. Yeah.
And it's also 15% better at insulating the heat. And there's a reason for that. You'd say, well, why? Graphene is a thermal conductor. Well, the percolation threshold moves it to the outside. In other words, the ability for it to soak into the material, percolation threshold. So it moves the particles to the outside of the little bubbles that are formed when it becomes a foam.
Okay.
And so the actual, there we go, we'll do this. I'll use this piece as the graphene. The radiation, if it hits this way, it bounces off and goes back out. Now, if you try to run heat across the plane, it'll conduct.
Right.
But if you're doing radiation, it just bounces it back out. And
fascinating.
We even do a neutron espallation and stuff like that. Neutrons won't go through graphene. And they know that because graphite rods and control rods.
Sure.
Are the same thing. So what you do in to do radioactive reduction and stuff like that, you would mix a little graphene into, say, concrete. So you make the concrete really strong, and then you put the boron, which makes the concrete not so strong, and you'll end up with the same strength as like no boron concrete with the graphene in it. And also the graphene kind of like like a Plinko set, bounces the neutrons and the radiation around so that it has a better chance of hitting the boron, and the boron absorbs it. And so there you go. That's just basically what happens. But you have to have the non-functionalized, real, legit graphene to do that, because if you don't, you'll have reactions and stuff like that. The radiation will actually cause a reaction and degrade it and then burn the whole thing up.
Yeah.
But then, speaking of this piece, this is just fiberglass. Yeah. And this is as stiff as carbon fiber now. Let's be very specific, not aerospace carbon fiber, but like automotive grade carbon fiber.
Sure.
And it's just fiberglass, high grade fiberglass with the resin with the graphene mixed into the resin. And we have found that it compatibilizes or acts as a sizing agent. And so a sizing agent is just for fibers, for all the people who don't know. It makes it where it works good with the resin. That's all it does. It makes it where they blend and live together peacefully.
Okay.
So graphene actually enhances the sizing agents that are in the glass or the carbon fiber or the composite matrix or whatever, and makes it where you're using less resin. We found that you can use up to 30% less resin to wet out the part. So like with a boat, if you go down to Vonor, I can literally cut all of their budgets by 1/3 on resin just today.
That's incredible.
And you cut the weight of the boat, you got less waste, all that stuff.
Yeah.
And so we worked with a company out in Nashville once, who's like a leading edge person, and then another one in actually in just south of the river. They're really cool people, and they were producing parts that were 1/3 of the weight. Where once it was a 30-pound part, now it's a 20-pound part, and it was stiffer than the neat material part. So they were very happy with that, because boats, you want that rigidity, you want that, being stiff and a good hard part.
So I'm curious real quick, how's the process of adding, the additive that goes into it? Is it mixed in with pre-mixed in with the resin material?
That's correct. Like the epoxy, polyester or vinyl ester or whatever, because we even work with helium and, we worked with that as well. So we worked with all these different resin systems, and they all work very, very well. They
Sure.
really graphene. So you don't make anything out of graphene. You just supercharge whatever you're trying to get with graphene.
Yeah. Right.
And of course, there's the cost analysis curve, like, oh, I put too much in and it's not really giving, because the material has like a bell curve of where the right amount of material. So if you add too much, a lot of times you're just wasting money. But sometimes it'll do a stacking effect and make it more like graphite, and then you have really bad diminishing returns.
Oh, okay.
And we have learned that over and over and over. Like,
so you can be too much into an application.
Absolutely.
Too much in a mix. Is it high shear? Do you typically high shear that in, or can it just be blended?
You can. I've seen literal guys use a chopstick and mix it into polyester. Okay. But I recommend using a high shear system, like what they use at the factory for colorants and things like that, or any of their other additives. So that's where you probably want to do it from that level. But you can, if you get the weighting, and usually it's around for like vinyl ester or polyester or epoxies, you're sub 0.5%. It's actually more in the 0.1 to 0.3% realm, just depending on what's in the solids because that goes also with our paints. We do anti-fouling paints for the bottom of boats. And we actually have clinical trials that are like 5 years in the water with no growth.
Right.
And I dare anyone's paint. There is no paint even close doing to this, because we actually do it in like the intercoastal of Florida, where usually even with regular anti-fouling paint, within 60 days, there's already growth. So conventional anti-fouling paint has 60 days, there's growth on it. Ours, 5 years later, no growth.
Right.
So we are dominating in that department. We're getting that to work because, remember, we're a technology application of graphene, not the company that actually makes the paint.
Right.
So that's where we're working with certain partners, and they are getting great results. And it just takes time because, unfortunately, for a little while there were a lot of, I hate to say, fake graphene companies. They were selling like activated carbon or this or that, or even I even heard of fly ash being approached as a graphene, And so there's that sometimes happens and stuff like that. And then I can tell you there's about a handful of really good graphene companies. Irony is that just down the road, Vig Sherrill and General Graphene, they are an amazing graphene company. Now, they're not in competition with me because I make this bulk powder stuff, right? But they make the CVD for like all the electronics and all these really high end, where military grade applications of coatings, or they are. Let me say this and say it proudly: they are awesome, and I give them the credit. And then there's a couple companies in Europe, like like Black Swan is a good one. If they're from the Thomas Swan, all that, actually Manchester and all that, they're in that group. And we're talking with them actually, like, hey, this and this and this, because they're good at what they do, and they're interested in concretes and stuff like that, because we've been able to make concrete more like Roman concrete,
right? So
it lasts 1,000 years. Or we do the same thing with like asphalt, not the same thing, but we improve the properties of asphalt. So like, instead of these potholes in one winter, maybe it's like 3 winters from now, you'll get potholes, things like that. And that also goes hand in hand. We've been working with TDOT and UDOT and a whole bunch of Department of Transportations, and IOSHTO, I think, is the acronym for the national version of it. So it's just making things better. That's what we're doing, is trying to make
improving the strength, the durability. It's
especially fatigue cycle, like this composite right here. We learned that most of the composite elements, when you put graphene into the resin, you can go incredibly high on the loading strain, sometimes as high as 98% of the failure strain, infinitely, which is nuts. But we've seen that in certain applications, not all. And that's one of the things you have to have all these, I hate to say it, but there are these caveats, because graphene is only so good. It's very good, and it seems to work on almost everything to some degree. But there are people that have said things like Richard Branson said it. He said, "Oh, we'll make a CVD cabin on an airplane, and it'll be 1 atom thick, and we can look out of it, and it'll be this is amazing thing." And I'm like, "No, you won't. That'll never happen. Not only will that never happen, but everyone will die instantly from that. The plane will blow apart because yes, it is strong, but it's still only 1 atom thick.
Yeah.
And even if you made it out of tungsten, you know how strong tungsten is. It's
yeah.
incredible.
Yeah.
If it was 1 atom thick, it would just blow away in the wind.
Mm-hmm.
Graphene does hold up and makes this film, but I can just poke my finger through it. I mean, there's no question about that.
Sure.
So you just have to have realistic expectations of the material,
of course,
and then you'll get incredible things. And sometimes it surprises us. And one example was when ACCR took off, we moved into ballistic. That's what ACCR basically does is it does advanced composites that are more ballistic related. And so we were doing composite layups with different like Kevlars and different materials. And one material came up to be like a really good material, and that's ultra high molecular weight polyethylene. And, there's a company called DSM that made it, and they now are owned by Avient. And then Honeywell, they make their stuff. And then there's some other smaller companies that make like little batches of the material. But this stuff is what like modern ballistic armor is made of. And they just press it together and all this. And we were like, our little idea was that you could use a composite layup system and just do it that way. And we, that company evolved because at a certain point we were told, no, you can't have any more of these other companies, ultra high molecular weight polyethylene. You're completely cut off because you're doing all these wild things that they weren't really comfortable with, because we were willing to do uncomfortable things. I mean, I guess when you're desperate for money, you'll do, wild chicanery to try to make things work.
Right.
Or you think outside the box. That's really what's going on.
Lights a fire under you, right? You know?
And so when we got kind of cut off on that, that's when we started making our own polyethylene, and we put the graphene in the polyethylene. Why not?
Right.
And so what we were able to do is take a regular commodity grade ultra high molecular weight polyethylene that wasn't necessarily very, very special and not necessarily the greatest for fiber extrusion or something like that. And we were able to add graphene to it and make the fiber extrusions, and then make these 4-ply 090s that just blow away the industry. I mean, even just today, I had a Department of Homeland Security guy shoot one of our ballistic panels in a door for the school door system that we're looking at doing. And, he double tapped with the green tips twice in one spot, put the hole down the same hole. That's what you get for having a guy that's really good at shooting. But it didn't fail. And that's what mattered. At that point, it's like, oh, well, everything's off the table.
Wow.
It didn't fail. It absolutely worked. Everybody was impressed. We had a whole lot of people involved in seeing this happen.
And it was that you're talking a sheet that thin that you just held?
No.
Oh,
Actually, the rifle panels are like this.
Okay, gotcha.
So, fairly thin. But this was actually shot with a 308.
Wow.
And actually it has it. Yeah.
It's 308. Yeah, exactly.
That's not playing around.
No.
So 2,750 feet per second, M80 ball, and it's still in there. But you can see it didn't go through.
Did not. Yeah.
And so with the green tip system, because that was an armor piercing round that got double tapped, it's a little thicker because armor piercing means it pierces armor. So, it'll go through. But it doesn't go through when we go a little thicker and do a little trickery and, ballistic.
Just lodges right in.
Yeah, it just stays right there.
Just stays right in. Wow.
And I mean, they dropped rounds into it. You can probably put, a couple thousand rounds into this door with no problem. So good luck with a school shooter getting through that door. I mean, it's not happening.
Right.
I mean, unless the dude shows up with a 50 cal, and what are they going to do? A tank? I mean,
one of these Desert Eagles. No,
that's a 50 cal handgun.
Yeah,
that's actually easy to stop. That actually is stopped by this plate.
Oh, wow.
This actually takes 44 mags. Desert Eagle. It's just about every handgun known to man.
You're kidding. That thing.
Yeah.
I mean, wow.
And it's nothing. It's just super, super thin. This is called a 3A by the NIJ standard. And we actually have this NIJ certified. So we were the first to get any nanomaterial certified through the NIJ. They really did not want anything to do with that. And so when we showed them what we were doing and we educated them and showed them, and it's just how it is. You got to expect people to be like, I don't know. I mean, and we got it through. They were very happy with it because they're like, wow, this really works. And we also have a rifle plate that's flexible just like this. It's a little thicker than this, but it does the same thing. It holds the 308 just the same.
Sure.
And this is the fiber itself. We just tow it up and be done with it. And so we've been working on these wild things, like recycling plastics. This is polypropylene, good old polypropylene. And we just put graphene in it with the glass fiber. And, this actually is the recycled glass fiber at that from a wind turbine blade.
Sure.
Here. So, we're the synergy of these companies going, these entities that I'm a part of. I mean, if you work with us, you get what you want. I'll tell you that. There haven't been many people that have been left disappointed.
Yeah, I can imagine. I mean, you mentioned Department of Homeland Security, Department of Defense. I'm sure you get a lot of interest from this material. I mean, everything from, as you mentioned, Kevlar helmets to, uniforms. I mean, the equipment people are wearing today in the vehicles,
Oh yeah.
I mean, there's so many applications. I mean, what kind of feedback do you get from these guys? And I'm sure there's obviously they're like any, government agency or, entity like that. There's a process, you have to go through some hoops and obviously a process approval and going through the right channels before things move forward. So I'm sure that things like that take time.
Oh yeah, with the ballistic materials and stuff like that. Right now, we actually gel spin. Ironically enough, we do the gel spinning of that fiber in China. Yeah. So there's a lot of generals that are like, nah, you're not going to take that stuff and that's fine because they do have an alternative currently.
Sure.
But we're talking to those, those two big companies that kind of told us go away.
Yeah.
Now they're coming back and being very, very nice to us because they're like, huh.
Yeah.
That seems like it's legit. And a lot of these armor companies and stuff like that are now coming back to us and going, huh. Yeah. Well, there's a thing going on in a faraway land and nobody cares whether or not the material's made anywhere. We can get it in Japan or China or Indonesia. There's a couple places where we can have this gel spun. And they're like, can you do it here? Can you do that? Yes, we can do that. And so, I mean, it even gets so crazy because like, we do a lot of upfitting for vehicles in vehicles in Mexico. And so that was one of what I did not know until I got into this is that Mexico City is the #1 city for ballistic armor vehicles. It has hundreds of thousands of them. There's one company that does they do 3 to 6 vehicles a day. And that's and there's 30 of these kinds of companies in Mexico. And there's a way to tell if somebody's got an upfitted vehicle. You just put polarized glasses because the laminated glass shows up. It has this weird blue halo through it. Yeah. And so you do things like this thick. Yeah. And you can see how thin it. I mean, it's less than a 1/16 of an inch.
Oh yeah.
And it holds 44 mags. That's actually 2 right beside each other.
That's awesome.
And so this is the panel that's roughly. I have a flexible version of it, not a laminate version in my Tesla. And those panels weigh 6 pounds each. And so I have an upgraded Tesla Model S. That you could shoot 300, 400, 500 rounds of 9mm into the door. Just don't aim for the glass because then that fails. Because I don't make glass. That's one of the caveats with graphene is I haven't been able to do anything really with clear.
So you have your whole car wrapped in this, or just the door? Oh wow!
Yeah, the doors. Man. The doors are all taken. It's upfitted in that.
That's manner. Awesome. I would love to see that. You got to shoot me a picture of that, man.
Oh, it's just a regular. It looks like a regular Tesla.
Okay, all right.
Yeah, you can't tell. It's inside the aluminum, and it's so.
Come shoot your car then.
Please don't. I like that car, and I'm telling you, no body shop wants to work on a Tesla. So it's aluminum. You know, it's made out of aluminum, so they're kind of still. There's some of the companies are still trying to get on board with that.
Yeah.
And I don't want to have to go hunting for a new door skin or something like that. So we do all kinds of wild, wacky things. And having that open mind of like, since we have this magic dust, we just throw it into, oils, greases, things, all these different crazy coatings and all that wild stuff. It leads to very, very interesting things. And in our travels, we actually made some fibers that are in the future that we think would be very, very, very remarkable as well. And we've done composites that are very remarkable, and polymers. And we even, behind you, this is actually one of our testing offices. So back there somewhere is where we actually take graphene, we put it in aluminum, extrude it out, and make it conduct more like copper than the neat aluminum. Now, mind you, it's not aluminum. I believe this. So they measure things in the scale of the percentage by copper. So copper is 100%. So it's a 100 rating or 98. Depending on what temperature or the time of day. Blah blah blah. Who cares? But aluminum, usually the aluminum is right around in the 60s. And so when you get this aluminum into the 70s, that's a big deal because not only that, but it made it corrosion resistant because it's 1000 series aluminum that they use for transmission lines. And if you can, I believe it's every 1%, I think it's $1 billion of savings of electricity in the United States alone. So we're like interested in that. That's like a very, very neat thing. Unfortunately, the making metals conduct better via carbonaceous materials is kind of a black art. There's a lot of people who think they know how to do it, but they can't do it. And I am one of those people I guess, because I really don't know. I'm not. We get lucky sometimes. That's a in the future thing. So that's why we like things like that. But now if you want to make steel stronger, I can do that all day. And we've done sintered metals and stuff like that. We've done a lot of different, metals where we added graphene at certain weights and made them stronger and more. We even have, for all those material people out there that are listening, we make sintered products have a necking region in the failure strength. So at that point, they're like, no. Sintered products usually shatter like glass. And it's like, no, this does not. It actually really does neck out just like a neat product. So that's kind of a neat thing, and we've seen a lot of different neat phenomena and we've played with it. So I hate to say it, but graphene is interesting.
Oh yeah, man. I mean, there's so many. I mean, that's the thing. I mean, I know, some of your core markets. I mean, there's so many different applications. You get into coatings, you get into all sorts of, like aluminum. I mean, I think it's like die cast. Have you guys done anything with the die cast industries? And
I did it myself with aluminum back in the day. And made a fairly decent part out of a recycled aluminum part. And that's where it gets kind of neat, is that being able to like sprinkle it in recycled plastic or recycled aluminum and gaining back that strength without having to do like the total remelting or the total, reconditioning of the materials and stuff like that. With polymers, you just never get the strength back because it's, they degrade. But and of course, if you put like trash bags with PET with this, you have this amalgam of garbage. But if you add graphene to it, you can actually make it semi stable. You can actually you can alloy these polymers in a way. Now, some are more better than others. That's definitely true. Don't think that I'm going to make PEEK out of old trash bags. It's just not happening. Okay. And that's where realistic expectations of the product come into play. But I mean, if you want to, we are known to take like nylon, and I've done this with several different companies where we take the nylon in there, add the graphene, and it makes it like as strong as say 10% glass additive. So why that's important is that usually they use a 30% glass additive nylon because it causes all the machines to wear out if you go up to 40%, but they want that 40% strength. So if you add the graphene in there, now you have that, and the graphene actually acts as a lubricant inside all your twin screws and your injection molding machines. So then your dies don't wear out as fast. And you're this, and so now you got all the benefits of all the pros of the 30% because you're not wearing anything out. But not only that, you're making that stuff last longer, and you have the strength of that 40%, which would just absolutely obliterate all your tooling. So there's that is the kind of language that you have to do. Or with the tires, we're taking out 6 DDP, I think is the name of the element, where we're able to put graphene in there, make the tires tougher and better and this and that, because that element is now being like told in California, no, you can't use that anymore.
I see.
So
yeah.
We actually got famous for like a half second, Carbon Rivers did, for the 6 DDP. I think that's the name of it. I could be wrong. I'm not a tire person. There are people that are, and that's another thing. If you learn your lane and you learn, okay, think of it like a band. We go back to the original thing. I play guitar.
Mm-hmm.
I don't expect to play drums better than my drummer. If I can play drums better than a drummer, you need a new drummer. Okay. So I make graphene on the guitar.
Learn to focus on your lane, like stay in your lane. And
exactly.
And,
I might, I'm over here jamming out in the graphene guitar.
Right.
If this guy from the tire company, or this guy from the nylon company, or this guy from the such, they know their stuff.
Right.
Now I am asking them to play with me.
Sure.
So that's a little different than jamming out by yourself or jamming out to your favorite band.
Right.
But if you start playing with me, we're going to make good music.
Yeah, absolutely.
So that's kind of a crappy analogy.
Energy. Yeah. It makes sense.
That's what we're trying to do. We're not trying to tell people, oh, you have to reinvent the wheel. Because nobody's going to adopt anything that they have to redo everything for. Yeah. It's just not happening. Right. And that's why we made our ultra high melted polyethylene, instead of using it just composite and stuff like that. We made it where you could do either way, where you could press it, you could do it in composite layup. And then ironically enough, how we did it, we were able to do the soft armor systems just like this one.
Sure.
Just the same. So it's all the same fabric over and over and over and over again. And it makes it easier for the end guy to just go, oh, I just cut this out and I put it in a thing and go. And the same thing with the graphene. We're trying to make it where it's as easy as possible for people. So like with certain epoxies, it's the same thing. You just put it in like a super suspension or something like that.
What about additive manufacturers? I mean, guys in 3D printing, what are you guys doing?
In fact, on my YouTube, it'll show that I was the first person to use graphene on the BAM.
Okay.
So I was actually the first. I think we were with Professor Dadman at UTK. I'm going to name drop because he's a nice dude. Yeah. Him and I were the first people to 3D print with graphene, period.
Awesome.
And we did that, almost 11 years ago.
Wow.
And we did that with PLA and ABS.
Okay.
So we printed that. And then I went immediately from ABS to ABS carbon fiber and nylon carbon fiber with graphene in it. And I was working with, if you remember, Local Motors, mm-hmm. and the MDF and back then it was called the TAN deck, but now it's called the FCMF at UTK. I was working with all these people and like sprinkling the graphene and everything, and we were printing. And you finally get to print a large print thing, and with no curling, no defects, no nothing, and the Z axis is increased by like almost 100%. So it's almost like the part was injection molded.
Wow.
That's the jumps. The weld at the Z line is way higher, and they're all like, wow, that's really cool. And because it's not, you don't have to compensate for the curling and stuff like that and wild stuff. You just print it out, machine it, and it's done.
Right.
Because they always machine their stuff, on the BAM or on the, all those. And the Loki guys, they are actually some of the guys from Local Motors. They went and they did Loki. They're really great. Same thing. They did a lot of the research. I mean, those guys were actually the guys that were like hands-on this stuff. Mm-hmm. So, they know their stuff. These people, you got to pat people on the back, and they deserve it.
Yeah, absolutely. That's incredible.
I'm just the jackass that hands out the black dust. Honestly, at the end of the day, I go, okay, we're going to throw it in this, and we just do it.
Yeah.
It looks good. Okay. Someone else figure out all the legwork on that, because that company will probably.
That's incredible, though. I mean, there's just, it's got to be, I mean, you have such a fun job because you get to, you're always looking. I mean, you get to collaborate with, these other guys in the materials and experiment and play and, create new applications, new products. I mean, it's pretty, I mean, you got a dream job.
Yeah, actually, I could say that with a, well, I'm one of those people that I'm stubborn. Maybe I'm dumber than I am stubborn, but at the same
Yeah,
time, more stubborn than most. And what I mean by that is I am not going to work a job or do something that I don't want to do.
absolutely. Yeah.
If I'm not having a good time, like I'll tell you, one of the best times I ever had in my whole entire life was when I was like 17, 18 years old. And I was working at, of all places, Papa John's Pizza, slapping pizza out, topping it, and my friends and I were all just hanging out, being
You were
goofballs.
thinking at that time, man, we could print one of these things.
No, that was 1997. So no, nobody was
Yeah.
3D printing anything.
Right, right.
But I was literal Nick. Oh my God, I'm such an idiot. Anyway, that was a good joke though. But
Yeah.
we would just goof off, but I was having a good time. I would do that job with no problem. You know why? Because it was fun. And I
Sure.
didn't hate every day coming in.
Yeah.
If I hate, I tried one time. I tried to like, because you think about it, you take these jobs to supplement your music habit.
Yeah.
That's really what it is. It's not your music career; it's your music habit, right? So one of the jobs I took up was telemarketing, and I tried to work at one of those call centers, and I lasted about 2.5 hours, and they finally came in and said, "Tap out, bro. You're done. You're already." You're so bad at this. These old ladies eat you up for breakfast. You have no business being here because you seem to like to talk to these people, not sell them something.
Yeah, you're too empathetic. I mean,
Yeah, dude.
you're
Honestly,
not gonna.
I didn't believe in what I was selling. I was just
Of course
oh,
not.
you're
And
trying to.
Yeah, that's the key right there. You have to believe in what you're doing.
I had check marks against me right there. I didn't even believe in the product, and I didn't know how to do the job. So what am I doing?
Yeah.
I shouldn't be there. But when you believe in something and you're like, I have seen with my own eyes some wild stuff,
Yeah.
crazy stuff, incredible. A prime example, our race car, we take it out to Harper's Auto Square, and I have people kick the bumper because it is actually. So this piece is actually, I think it's 3 layers of fiberglass, right?
Mm-hmm.
Well, this is not the recycled glass, but our bumper is made of the wind turbine blades.
Yeah.
So I used one laminate section over it with the graphene infused resin. And now the joke is that everybody kicks it as hard as they can. And it's like an interactive thing. And it's a race car. Who would tell you to kick their race car? This guy, because I'm a complete, and it's electric too. So it's like even more ridiculous. So you do like quiet burnouts, like there's no engine roaring, you just go and just burn up the tires. So that was kind of fun because that's entertaining.
Sure.
But that's what we do, is we sit there and we do what we love doing. And
absolutely.
So that's why like everything is for a purpose at the end of the day. You just might not know what that purpose is.
Absolutely.
You might stumble into something that you love and you didn't even know it. And that's why I have a philosophy in life where it's like, try anything, I mean, if it's not against your morals and principles, if you're like, man, I think I'm going to go skydiving, instead of sitting here and daydreaming it over and over and over.
Right.
You got this phone right here that literally goes skydiving near me. Watch this.
Right. Yeah.
Skydiving near me.
Pulls her right up.
Boom. Knoxville Skydiving, Tandem Skydiving Center. I can literally call them and I can learn how to skydive tomorrow.
Right.
So, I mean, I'm taking that as an example because some people have these dreams and they just don't act upon it.
They don't follow it. Yeah. You're absolutely right.
And it's sad. And, and I get to go to work as a dream because I'm over here. This thing is like this building. When you come here, everybody that comes here, they kind of describe it pretty accurately as like a Skunk Works meets Wonka factory. Because they got this crazy hairdo guy going on, and you don't know what you're going to see. You're going to see, I mean, who has this? And just sitting around on the table like, you can touch it and feel it and look at it. All right, you want to go back and shoot it? Let's go. And when you do that, I mean, I literally just shot stuff for, some state representatives and some people and stuff like that this morning. And I mean, who gets to do that?
Yeah.
does that? Nobody.
Right.
Well, everybody should though. I have a philosophy on that, where it's like all of our employees here at Carbon Rivers and ACCR and all that, well, actually, I'm basically the only real employee of ACCR.
Mm-hmm.
That's a long story.
Yeah.
How the company is designed. But all the people here love their job, and I hope that they love their job. And it's not like a Steve Carell, The Office type. I hope they love the job. I actually hope, I don't want to be the guy that's like, oh yeah, I really love my job and everyone else must love it, and then they actually hate it.
Yeah.
I don't want anybody to hate, in fact, today, one of our former employees, he came in to hang out with some of our employees today, Yeah. There's no hate in that.
That's cool.
He was moving and he wanted to move to a different kind of company and this and that. And it's like, cool, good for you.
Yeah.
Wonderful, and then he comes and visits. And we have that over and over. All the people are kind of family here. And if you are at a job where everybody is just this distant, I don't care about you over and over and over, how are you possibly going to get anything innovative done?
Yeah.
It's just not going to happen.
No, you got to work together. Yeah. I mean, it's that's what it takes. So you guys are located in obviously Knoxville, as you mentioned. We're at about the 1 hour mark. So let's wrap up, if you would kind of share, where our listeners can learn more, obviously about Carbon Rivers and, website, location. Tell us a little bit about the company before we close out.
It's one of the websites. So it's all under one umbrella, but it's Carbon Rivers, www.carbonrivers.com. Boy, I said it. But then ACCR is theaccr.com.
Okay.
And then we have some other little offshoots and stuff like that. If you get to either of those two entities, you will certainly get to what you're looking for. So if you're interested in, these wild technologies, because we do consulting, we help people with like why we even got into the recycling of glass fiber for Carbon Rivers was literally someone came to me with 2 thimbles and said, can you make this bigger?
Yeah.
And we certainly did. I mean, with a little bit of DOE money, we made a giant operation and literally fixed an industry. I mean, we're on the target to actually be the only viable solution for the wind turbine industry, but not just wind turbines, but because European and California standards are making it where you have to have recycled materials for automobiles, we're fixing it for automotive. And boats are seeing the same thing. They're seeing kind of the same mandates.
Right.
So we're now fixing that for them before they even have a problem. Isn't that great? I think. So that's kind of the idea. If you have some wacky, I mean, we're doing a couple other odd projects like with fly ash and a couple other things here and there, and we're doing all these things where it's like, we back burner it, and if someone comes along and they say, hey, I have money for this, or DOE or SBIR proposal comes up, it's like, we can win that, we can do this, and we can get this to the next step, let's do it. And we are not opposed to that. It's just, we have had a couple times where somebody said, hey, can you make golf clubs out of graphene? And I'm like, no, there's no market in that. And no, I can't. Graphene isn't, you don't make things out of graphene, you enhance graphene with it, Right. And I've had things like that. They had no money to do something. And I mean, I'm sorry, but this is a business. It's not a charity.
Sure. Yeah.
I love doing charitable things though, but you see that you have that dynamic where it's like, now if someone says, hey, can you give me 10 grams of graphene in a little bottle so I can try my little model RC car out?
Right. We can run our own. Yeah.
Oh yeah. I'm
Go for it.
Here, take it. I don't care about that. I don't care about 10 grams. I have literal tons of this material. Go ahead. Sure. Have fun. I mean, I said it the other day to somebody. I said, I have all this graphene here. Guess what? I don't want it. Take it. Everyone buy it. Go away.
Yeah. Yeah. Right.
So it's one of those things where, if we have a technology that kind of fits your requirements, we'll jump in there. Or if we don't, and you think we do, we'll try. We'll figure it out.
Yeah.
It's just one of those things.
Well, I've got I think I double checked those, the 2 websites, carbonrivers.com, theaccr.com. They're scrolling at the bottom. We'll post the links on our show page. Nick, this has been fantastic. We got to do this again, man. I mean, there's so many things I'd love to get into. We just, you run short of time, but we definitely got to have you back on. You're a great guest to have. Obviously, this is not, you've told me before, this is not your first podcast. You've done these before, and I can certainly tell. I mean, it shows.
I mean, I can ramble for like hours on this stuff. I mean, we didn't even get into like some of the things, but we'll get into some other things.
Yeah, well, let's do a follow-up. And by the way, are you going to be at CAMX down in Atlanta?
I believe we are. And we are actually going to do, we're going to do the kick plate. In other words, where you get to interact and kick the fiberglass plate over and over and over again. Yeah. I think I'm working on that, I think next week, actually, of all things, or maybe the week after. We were supposed to do it before, but like a bunch of things pile up, and these little side quests of like, showmanship, because that's what we call it. They're not paramount to making money.
No.
They're cute.
They get interest and they get eyeballs, right? I mean, that's all the big thing. Well, let's do a follow-up actually, but I'd love to do something at the show, but I'd love to follow up with you even before then, have you back on and maybe highlight some of the things that you guys might be doing there at the show. Absolutely. And we'll stay in touch and have you back on real soon for sure.
Absolutely. And if you feel like coming by and visiting us, we would be very happy for you.
Oh yeah. I'd love to, man. That'd be fun. Do like an in-person. That would be great. Yeah.
Oh yeah. We'd have like that'd be very, very fun.
Okay.
Excellent.
We'll plan on it. Nick, thanks so much. Again, you can find, I've got the two websites scrolling at the bottom. We'll post it on our show page for all of our listeners. That is Nick Ciparro. He is, again, the Chief Technology Officer at Carbon Rivers. And Nick, it's a pleasure, man. Look forward to staying in touch and getting back together again and doing a live in person there at your facility. That'd be fun.
Yeah, maybe we'll shoot something too. Why not?
Hey, I would love that. Hey, just let me know. I'll bring the arms. I'll bring the 9mm and maybe the AR too.
Oh yeah, we have plenty of those. So yeah, we can all have a little bit of fun. Yeah.
Oh sure, that's what it's fantastic. About.
All right.
Thanks again. All right, thanks, Nick. Appreciate it, man.
All right.
Let's see. All right, that's a